Hello viewers, we are going to look at trusses, and under trusses we are going to consider how to determine the reactions in trusses. And so we've been given this question and we're asked to determine the reaction in the beam below. So this, if this is 60 degrees and this is 60, means this one is 60 degrees too, an equilateral triangle. So this will be 60 degrees, this will be 60. This will be 60 degrees. Okay, so since we've gotten this, we know that the length is given to, the entire length of this is given to 6 meter, and then from here to here is 3 meter, from point A to point B is 3 meter, and then from point E to D is 3 meters. So since we are asked to determine the reactions, we can call this RA, the reaction in A, and then call this RD, the reaction in D. And so in order to move further with the solution of this question, we have to make a mathematical statement that let the summation of upward forces, these are the upward forces or the upward reactions, be equal to summation of downward forces. These are the downward forces that we have. And so in implementing this mathematical statement, we have RA, which is this one, plus RD, which is this, equal to 2 kilonewton. These are the upward forces, and equal to 2 plus 4. So these are the downward forces. And so when we sum that out, we are going to have RA plus RD equal to 6 kilonewton. We call that our equation 1. And then we have to also determine moment, because in the moment, in determining the moment, it will help us to, find the reactions. So in order to determine moment, we have to take into consideration this sign convention that all clockwise moments will be positive and all anti-clockwise will be negative, as represented here. So when we come to this point, and we also say that at this point, that let summation of moment at point A be equal to 0. What this implies is we are going to, all the forces we have will turn to point A, and then we equate whatever we have to 0. So this one will turn, okay, if this force is actually turning to A, it will turn at the middle, because this is an equilateral triangle. It will turn at the middle, and the middle will be 1.5 meter, because from here to here is 3 meters, so it will be 1.5 meter, and it will turn clockwise. And so we come to this other force here, it will turn at the middle will be 1.5. So if we say from here to here is 1.5, from here to here is 3 meter, and from here to here is 3 meter, it means half, as from here to here will be 1.5. So it will turn 1.5, this is 1.5 here. So 1.5, that is from here to here, will be 1.5, and from here to here will be 3. So if we have 1.5 plus 3, 1.5 plus 3 meter, that is from here to here, we are going to have this one to turn 4.5 meter. So this one also will have to turn this way to meet with D. So let's explain it here. Now, if we are taking moment about point A, it means we are going to take all the forces will move down to where point A is. This one will move, this one will move anti-clockwise. So for the first force, which is 2 kilonewton, it will move 1.5 meter, because it's acting at the middle. Remember, from here to here is 3. So it will move 1.5 meter to point A. So that's why we have 2 times 1.5. And then for the second force, 4 kilonewton, will move from this point down and then turn to this point. So it will cover 1.5 in this first part, and then it will cover 3 meter in the second part. So that is why we have 3 meter, which is from here to here, and plus 1.5 meter, which is from here to here. So we have it to cover 4.5 meters. So that's why we have 4 times 4.5. Then the next one is RD. RD is going to be negative, because it is anti-clockwise, this one will be positive. Because it is clockwise, this one will be positive. So RD is going to be negative because the arrow will have to move up this way to meet the point A. And it's negative, and it's going to cover this entire distance, which is 6 meters. So that's why we're having minus RD times 6, and then we equate it to 0, because we said that summation of moment about point A is equal to 0. And so when we do this mathematics, we are going to have 3 this times this, 2 times 1.5 will give us 3, 4 times 4.5 will give us 18, and then we have this RD times 6 will give us minus 6 RD. And so when we add this, we have 21 minus 6 RD equal to 0, which is the same thing as saying 6 RD equal to 21. That is, this 21 will cross the sign of equality. When you cancel out the negative sign, it will give you positive. So because we are looking for RD at this point, we divide both sides by 6, and when we divide both sides by 6, we have 3.5 kilonewton to be the value of RD at this point. So the reaction at this point is 3.5 kilonewton. And so for us to determine the value of RA at this point, we have to go back to our equation 1, and the equation is RA plus RD equal to 6 kilonewton. Now we've gotten the value of RA, so we can use this equation to determine the value of we've gotten the value of RD, so we can use this equation to determine the value of RA. So from equation 1, we have that RA plus RD equal to 6 kilonewton. That's this equation 1. And then RA from here will be equal to, so it means this RD will cross the sign of equality and it will become negative. So that's why we have it to be 6 kilonewton minus RD. And so we can now bring in the value of RD here, so that we have 6 kilonewton minus 3.5 kilonewton. And then the value of RA becomes 2.5 kilonewton. So basically, this is how to determine reactions in a beam when you are given the forces and the reactions. Thank you.